Some nights the sky holds a kind of stillness that feels almost too quiet to be real, the kind of dark that settles into a room and asks nothing of you at all. If this feels like a good place to rest tonight, you're welcome to stay. Now, let's drift. There is a question that has followed scientists for centuries, quietly, patiently, the way a shadow follows a candle. It is a simple question, almost childlike. What is empty space, really? Not the space inside a closet, or the space between two chairs in a kitchen, but the space beyond all of that. The space between stars. The space inside the room you are lying in right now. The space between your skin and the edge of this voice reaching you through the dark. For a long time, people imagined that space, true space, was simply nothing. A blank page. An absence. The word itself, empty, seems to promise stillness, a kind of silence so complete that nothing could possibly live inside it. But researchers have found something quieter and stranger than that. It seems that nothing in the way we usually picture it may not exist at all. Not even out there, far beyond the edges of galaxies where light takes millions of years just to arrive. Picture for a moment the space between two distant stars. No air, no light passing through at that exact instant. No sound, because sound has nowhere to travel without something to carry it. It feels in the imagination like the purest kind of emptiness a person could ever conceive. And yet scientists are still exploring what is actually happening in that space, and what they have found does not look like emptiness at all. It looks more like a fabric, low and easy breathing without anyone noticing. There is a word physicists use for this, a word that sounds clinical at first, almost cold. Vacuum. It is the word for a space with nothing in it, or as close to nothing as anything can get. But here is the soft part, the part that settles slowly into the mind the way warmth settles into a blanket. Even a vacuum is rarely, if ever, completely empty. Out in the space between galaxies, in the most isolated stretches of the universe, there are still atoms drifting. Not many. Sometimes only a handful in a space the size of a room. But they are there, scattered thin and slow, like the last few snowflakes after a storm has mostly passed. And even in laboratories here on Earth, where scientists have built machines specifically designed to remove every last trace of air, every last particle, something always remains. A trace, a whisper, as if space itself resists the idea of being completely hollow. It seems that true nothingness, the kind philosophers once imagined, the kind that holds absolutely no trace of anything at all, may not be something the universe is willing to allow. There is something quietly comforting in that thought if you let it settle. The idea that even in the loneliest corners of existence, in the coldest, darkest, most distant places imaginable, there is still something, a trace, a presence. Space, it turns out, may never truly be alone. Researchers who study this work in machines called vacuum chambers, sealed rooms built to come as close as possible to true emptiness. And even there, even inside steel walls designed for exactly this purpose, the silence is never absolute. Pressure can be lowered and lowered again, but there is always a final stubborn trace that refuses to leave. Scientists suggest this happens because particles are constantly gently leaking from the surfaces around them, the walls themselves quietly releasing tiny amounts of matter into the space they were trying to clear. As if matter in its own slow way does not like to be entirely absent either. The mind tends to interpret silence and emptiness as the same thing. A quiet room feels empty. A quiet night feels empty. But physics seems to be suggesting something different, something gentler. That stillness and emptiness are not the same at all. A space can be almost perfectly silent and still be full of something too small, too faint, too quiet to notice. Maybe that is true of more than just space. There is a particular feeling some people describe lying in the dark, just like this in the hour when the day has gone soft and unfocused. A feeling of being completely alone and yet not quite, as if the room itself is holding something faint and steady, even when no one else is there. Psychologists often note that this sense of presence in solitude is common, something the mind creates almost on its own, perhaps because true aloneness, like true emptiness, is rare. Out in the depths of space between one galaxy and the next, there are regions called voids, vast, almost unimaginable distances where galaxies are sparse, spread thin across the dark like lights left on in a city long after everyone has gone home. Some of these voids stretch for hundreds of millions of light years, and still scientists have found they're not without structure, not without trace. It may be that this is simply how the universe is built. Layer upon layer of presence, faint and quiet, even where vastness seems to promise nothing at all. There is something in this that feels almost like permission. Permission to exist quietly without needing to be loud or full or constantly occupied and still be something. Still be real. Still be part of whatever this is, this slow unfolding universe breathing in its low and steady way. The mind lying here in the dark might begin to wonder what else has been mistaken for emptiness. A quiet thought, a pause between words, a long stretch of night with nothing happening at all. Maybe none of it was ever truly empty. Maybe it was only resting. And in that resting space between one breath and the next, scientists have found something even stranger waiting. Something that does not simply sit still, but flickers faint and brief, like a thought that almost forms and then lets go. That part of the story is still ahead. For now there is only this, the dark, the quiet, the soft, steady hum of a universe that may never be fully empty. Let it stay that way a little longer. There is a name for that flicker, the one that almost forms and then lets go. But before reaching for it, there is an older story worth drifting through. First one that begins long before laboratories and machines, long before anyone could measure anything at all. For most of human history, the idea of empty space troubled people in a quiet, persistent way. Ancient thinkers wondered whether such a thing could even exist, whether a space with truly nothing in it was even possible to imagine, let alone create. One philosopher centuries ago proposed that nature itself resisted emptiness, as if the universe had some quiet instinct to fill every gap the moment it appeared. It is a strangely tender thought when you sit with it for a while. The idea that the world might dislike being hollow, that it reaches gently to fill whatever space opens up. For a long time that idea simply sat there unproven, more feeling than fact. It took many lifetimes before anyone found a way to test it. The shift began with something as ordinary as weather. A scientist working in the 17th century became curious about how high water could be pulled up through a tube using suction, the same basic principle used in simple pumps of that era. He noticed something odd. No matter how carefully the tube was built, water would never rise above a certain height, roughly 30 feet and no further. So he wondered if perhaps something else was happening, something invisible, pressing down from above. He built a different kind of tube, one filled not with water, but with a heavier liquid mercury sealed at one end and turned upside down into a small dish. The mercury dropped slightly, leaving a small gap at the sealed top, a gap with nothing visible inside it at all. People at the time stared at that little space the way someone might stare at an unfamiliar room in their own house. What was up there? What filled it? Researchers have found, looking back at this moment now, that he'd created one of the first reliable vacuums ever observed by human hands. Above the mercury sat a space, empty of air, empty of liquid, holding almost nothing at all except for the faint trace of mercury vapour drifting up from below. It seems that nothingness, once captured in something as small as a glass tube, was no longer just a philosophical question. It had become something you could look at, something you could hold in your palm and turn slowly in candlelight. There is something almost moving about that. A space too small to matter, and yet large enough to quietly answer a question people have been asking for centuries. Not long after, in a different part of Europe, a mayor with a curious mind built something far larger to make the same point unmistakably visible to anyone watching. He created two metal hemispheres fitted together to form a hollow sphere and pumped almost all of the air out from inside. Then he asked teams of horses 8 on each side to try pulling the two halves apart. They could not. The horses strained the ropes, pulled tight, and still the sphere held together, sealed not by force but by the simple absence of air inside it. The empty space within was doing something. It was not idle. It was not passive. It was holding two pieces of metal together with a strength that seemed almost impossible for something built from nothing at all. What we understand so far suggests that this happens because air outside the sphere presses inward from every direction, evenly, constantly, the way water might press against the walls of a container from the outside. Remove the air from within, and that outside pressure has nothing pushing back against it. The emptiness inside becomes in its own quiet way powerful. There is a strange comfort folded into that image. Something hollow, something seemingly without substance, holding firm against the pull of horses, as if absence itself can have a kind of quiet strength, simply by existing the way it does. The mind tends to interpret strength as something loud, something visible, something pushing outward and demanding to be noticed. But this kind of strength was different, silent, invisible, felt only in what it refused to allow. From there, the understanding of empty space slowly deepened. Scientists began to realize that air itself has weight, that it presses down on everything beneath it all the time, in ways too constant and too familiar to ever really feel. We live submerged in an ocean of air, never noticing its pressure, the same way a fish may never notice water, and evidence suggests that the very emptiness above that early mercury tube, that small invisible gap, was simply the absence of this invisible ocean, a tiny window into a place where air's weight could not reach. It is a curious kind of mirror when you think about it. The first vacuum people ever truly observed was created not by removing something dramatic, but by quietly stepping outside the reach of something we usually never even notice is there. Maybe that is true of certain feelings too. The ones that only become visible once the noise around them quietly drops away. As scientific tools became more refined, scientists are still exploring just how complete a vacuum could ever truly become. Pumps grew more powerful, chambers grew more precise, and yet no matter how advanced the equipment, something would always linger. A few molecules drifting slow and faint, refusing to be fully swept away. It began to seem, the deeper this was studied, that complete emptiness might not simply be difficult to achieve. It might be something the universe quietly refuses to allow, the way a held breath eventually gently lets itself go. There is a particular stillness in space documentaries, in those long telescope images of distant nebulae, that makes emptiness look soft, almost inviting, like a dark blanket stretched endlessly outward. But this slow unfolding history, this story of Mercury and metal hemispheres and horses straining against silence, suggests something gentler still. That emptiness was never simply absence. It was always in some small way still listening. Astronomers later turned their instruments away from glass tubes and toward the night sky itself, wondering whether the same rules might apply far beyond Earth. Out past the moon, past the orbit of the farthest planets, into the long dark stretches between stars. And what they began to notice in the faint readings their instruments returned would later open into something even more delicate than a tube of mercury or a hollow sphere of metal. But that part is still ahead. For now there is only this, a small gap of nothing sitting quietly above a thread of mercury, a sphere holding firm in the hands of silence, a history of careful, curious people reaching gently towards something the world seemed almost reluctant to reveal. Let the night hold that thought a little longer. soft and unhurried, the way mercury once settled slow and certain inside a glass tube turned toward the dark. You said ban la chins a viet kick ban ting ang ke chuyện khoa học trước khi ngu trên kênh YouTube. Bạn có màu sắc kể chuyện độc đáo hấp dẫn riêng biệt mang đậm đi. There is a quieter layer to all of this one that sits just beneath the calm surface of empty space, and it begins with a question that sounds almost playful at first. Can nothing ever truly stay still? By the early part of the 20th century, scientists had already accepted that a vacuum was never perfectly empty in the practical sense, never fully free of stray molecules or faint traces of matter. But a different kind of emptiness was waiting to be discovered, one that had nothing to do with leftover atoms or imperfect machines. This emptiness lived at a much smaller scale, far below anything visible, far below anything a hand could ever touch. To reach it, physicists had to set aside the idea of solid, dependable stillness and step into a much stranger way of seeing the world. A field of study called quantum mechanics began to suggest that at the smallest scales the universe does not behave the way it does in ordinary life. Objects do not simply sit in one place waiting. Energy does not always behave the way intuition expects. One of the central ideas to come from this field carries the name of a German physicist, Werner Heisenberg, and it is often called the uncertainty principle. In simple terms, it suggests that there is a fundamental limit to how precisely certain pairs of properties like a particle's exact position and its exact momentum can ever be known at the same time. The more precisely one is measured, the less precisely the other can be known. It sounds at first like a problem of measurement, like something that better tools might one day fix, but researchers have found that this is not a flaw in our instruments at all. It is something woven into the fabric of reality itself at the smallest possible scale. There is something gentle in that idea, if you let it settle slowly. A universe that does not insist on being fully known. A universe that holds a little mystery in reserve even from its most careful observers. This uncertainty reaches into empty space in a way that feels almost impossible to picture. Even in a region with absolutely no matter, no light, no warmth, energy itself cannot settle into perfect stillness. There is a related idea here called the energy-time uncertainty relation, which suggests that for extremely short moments, energy can fluctuate, appearing and disappearing faster than it could ever be directly observed. Out of this fluctuation, something curious seems to happen. Pairs of particles, sometimes called virtual particles, can briefly appear in what looks like complete emptiness, only to vanish again almost as quickly as they arrived. They are not lasting things. They do not linger the way ordinary matter does. Studies indicate that they exist for such brief slivers of time that they almost seem to borrow their own existence, returning it before anyone could notice it was gone. It is a little like watching a single breath cloud against cold night air there and then, not there, leaving no trace except the faint memory that something for an instant was real. Scientists are still exploring exactly how to describe what this means for the deeper nature of empty space, but one interpretation has become widely accepted. The vacuum in this sense is not a stage with nothing happening on it. It is closer to something quietly alive with motion too small and too brief to ever be caught directly, a constant soft flickering beneath the threshold of detection. The mind tends to imagine emptiness as something frozen, something without motion or change, the way a still photograph holds a moment perfectly silent. But what physicists are describing here is closer to a heartbeat too faint to hear present everywhere, even in the coldest, darkest corner of space you could ever imagine. There is a particular kind of comfort folded into that thought when you let it rest a while. The idea that even in absolute isolation, even somewhere with no stars, no light, no observer of any kind, the universe is still gently, quietly active. Never completely silent, never completely still. It seems that this restlessness is not separate from the structure of reality. It may be one of its most basic ingredients present even before stars formed, before planets cooled, before anything resembling a person ever existed to wonder about any of it. Physicists sometimes describe this using a term called the quantum vacuum, distinguishing it from the simpler, more practical vacuum created in a sealed chamber back on Earth. The vacuum chamber, despite its careful engineering, can never fully escape the deeper quantum vacuum underneath it. Even with every molecule removed, even with pressure lowered, as far as technology allows, this finer layer of fluctuation remains untouched by pumps or seals or any tool built by human hands. What we understand so far suggests that this fluctuation carries real consequences, measurable ones, even though the particles involved come and go too quickly to ever directly observe. It shapes how certain forces behave at extremely small scales. It quietly influences interactions between particles in ways physicists have learned to calculate even without ever catching the fleeting particles themselves in the act. There is something almost tender in that, the idea that something can leave a trace, can shape the world in small certain ways without ever needing to be fully seen. Maybe there are moments like that in ordinary life too. Brief, quiet influences that pass through unnoticed and yet somehow still leave the world slightly different than it was before. Lying here now in the soft dark of this hour, it can feel strange to imagine that the space surrounding this very room, this quiet stretch of night air, carries within it the same flickering quality found in the depths of intergalactic space. Not loudly, not in any way the senses could detect, but quietly at a scale too small to ever reach awareness, energy borrowing itself for the briefest possible instant, then returning it just as gently. And what scientists discovered next is something the body has always carried inside it, without ever fully realizing. You said bạn là chuyên gia viết kịch bản tiếng Anh kể chuyện khoa học trước khi ngủ trên kênh YouTube. Bạn có màu sắc kể chuyện độc đáo hấp dẫn riêng biệt mang đậm đi. The body has always carried something quiet inside it, something that has nothing to do with thought or breath or heartbeat and yet sits at the very foundation of all three. To understand it, the story has to slow down even further down past atoms, down past the particles that make up atoms into a stillness that, as it turns out, is never quite still at all. Physicists have a name for the lowest possible energy a system can ever have. They call it the ground state. It is the resting point the quietest a particle, an atom, or even a field of energy can ever become. For a long time it seemed reasonable to assume that this ground state would mean something close to absolute calm. No motion, no leftover energy, nothing. But studies indicate that even at this lowest possible state, energy never fully disappears. There remains a small, persistent amount, one that cannot be removed no matter how much cooling, how much isolation, or how much careful engineering is applied. Physicists call this zero-point energy, and it appears to be a basic feature of nature itself, present in every quantum field, everywhere, all the time. It is a strange kind of permanence when you think about it slowly. A baseline hum that the universe never quite lets go of, the way a held note continues to vibrate softly, long after the rest of the room has gone quiet. This becomes easier to picture through something simple, something almost domestic in feeling. Imagine a swing hanging from a branch on a still evening. Push it and it sways back and forth, gradually losing height, gradually slowing until eventually it seems to stop. In ordinary experience, stillness feels final, but quantum systems do not behave like ordinary swings. According to the mathematics describing this kind of motion called a quantum harmonic oscillator, a system can never fully reach zero. There is always a small, irreducible amount of motion left over, even in its lowest possible energy state. The mind quietly registers stillness as an ending, a clean and total halt. But what we understand so far suggests that the universe rarely offers anything quite that absolute. Even at rest, there is a flicker of motion too small to ever fully eliminate present in the coldest places imaginable, present even at temperatures approaching absolute zero where nearly everything else slows to a near halt. There is something about this, if it is allowed to settle slowly. The idea that complete stillness, the kind without any motion left at all, may simply not be something nature permits. As if even rest carries with it a small quiet pulse, too faint to disturb anything but too persistent to ever fully vanish. This same zero-point energy reaches into the empty space discussed earlier, the space between stars, the space inside sealed laboratory chambers, the space surrounding this very room tonight. Even a perfect vacuum one with every stray atom carefully removed would still carry this underlying hum, this baseline vibration belonging not to matter, but to the fields that fill all of space, fields tied to electricity, to magnetism, to the forces holding atoms together. Neuroscientists have observed something distantly similar inside the resting human brain, although on an entirely different scale and through an entirely different mechanism. Even when a person is doing nothing at all, lying quietly in the dark with eyes closed, brain activity never drops to zero. There is a kind of background hum there, too often called the default mode network, a quiet pattern of activity that continues even during rest, even during the soft, unfocused drifting that happens just before sleep arrives. It's worth being careful here, because these two kinds of stillness, the quantum vacuum and the resting mind, come from entirely different sciences and entirely different scales of nature. They are not the same phenomenon, but there is something quietly poetic in noticing that both in their own separate ways seem to resist total silence, as if neither the universe nor the mind is built for complete and absolute rest. Maybe rest in both cases was never meant to mean total absence. Maybe it has always meant something softer, a lowering, a settling, not a stop but a slow, steady hum beneath the surface of stillness. This zero-point energy is not simply a theoretical curiosity sitting quietly in equations and never touching the physical world. Researchers have found that it has measurable consequences, subtle but real, showing up in extremely precise experiments involving atoms cooled to temperatures just barely above absolute zero. Even there, in conditions colder than anywhere naturally found in the universe, atoms continue to show a small amount of irreducible motion, exactly the amount predicted by zero-point energy calculations made decades earlier. There is something almost reassuring in that kind of consistency. A universe that even in its quietest, coldest, most extreme corners behaves the way the mathematics gently predicted it would long before anyone had the tools to look closely enough to check. It seems to invite a small, soft thought, one easy to carry into sleep, that perhaps nothing in this universe, no matter how reduced, how cooled, how emptied of everything else, is ever truly without some quiet trace of energy remaining inside it. Not loudly, not urgently, just present the way a low hum might rest beneath a quiet room felt more than heard. And it is this very hum, this same underlying vibration of empty space, that scientists would eventually learn to measure in an entirely unexpected way, not through cooling atoms or studying distant stars, but through two small, ordinary-looking metal plates placed close together in a laboratory and left alone to see what space itself might quietly do between them. Two metal plates placed close together in a quiet laboratory may seem like an unlikely place to look for proof that empty space is alive with faint motion. There is nothing dramatic about the setup. No wires sparking, no visible light, nothing that would catch the eye if you walked past it in a hallway. And yet what happens between those two plates would eventually become one of the gentlest, most convincing pieces of evidence that the vacuum is never truly still. The story begins with a Dutch physicist named Hendrik Casimir working in the middle of the 20th century. He was not trying to prove anything dramatic about the universe. He was investigating a far more practical question related to forces between very small particles suspended in solution. But in working through the mathematics, he stumbled upon something unexpected, something that seemed to reach far beyond the original question he'd been asking. Casimir proposed that if two uncharged metal plates were placed extremely close together, closer than the width of a human hair, something strange would happen. The plates would be drawn toward each other, not because of electricity, not because of magnetism, not because of gravity, which at that scale would be far too weak to matter. They would move together because of the empty space between them. It sounds at first almost impossible. How could nothing pull on something? But researchers have found that the explanation lies in that same quiet hum discussed earlier, the soft, ever-present fluctuation belonging to the vacuum itself. Picture for a moment all of space filled with countless invisible waves fluctuating gently in every direction, at every possible wavelength far too small and far too brief to ever observe directly. Out in open space with nothing nearby to interfere, these waves exist freely in every size, every frequency, every direction at once. But place two metal plates close together and something changes. Only certain wavelengths of these fluctuations can fit neatly in the narrow gap between them, the way only certain notes can resonate inside a short length of pipe while longer, lower notes simply do not fit. Outside the plates in the open space surrounding them, every possible wavelength remains free to exist. Inside the gap, many are quietly excluded. This creates an imbalance gentle and almost impossible to imagine. Slightly more of this background fluctuation pressing in from the outside than is able to exist in the narrow space between the plates. And so very slowly, very faintly, the plates are nudged toward each other, pulled not by any ordinary force but by an imbalance in the texture of empty space itself. It seems like something from a quiet dream, the idea that two pieces of metal could be drawn together simply because the emptiness around them was slightly less crowded than the emptiness between them. And yet decades after Casimir first proposed it mathematically, scientists building extremely sensitive equipment were able to measure this effect, directly confirming that the attraction is real, and that it matches with remarkable precision what the equations had predicted long before the technology existed to detect it. There is something almost moving in that kind of patience, a prediction waiting quietly for half a century until instruments finally became sensitive enough to listen closely enough to notice it. The force involved is impossibly small, far too faint to ever be felt by human hands or seen by human eyes. It only becomes meaningful at distances smaller than the width of a strand of hair in carefully isolated laboratory conditions, shielded from vibration from air currents, from anything that might disturb a force this delicate. And yet evidence suggests that this same effect at a much smaller scale may quietly influence how tiny mechanical devices behave, devices built at scales close to the width of a single cell, where forces this faint can no longer be ignored. The mind tends to imagine forces as things that push, that shove, that announce themselves clearly. But the Casimir effect is the opposite kind of force. It is the quietest possible push imaginable, arising not from something added, but from something subtly missing. A kind of attraction born from absence rather than presence. Maybe that says something gentle about closeness in general. That sometimes what draws two things together is not something added between them, but something subtly taken away, a narrowing, a quieting, a space made just slightly different from everything around it. There is another way to think about what this experiment revealed, one that settles a little more slowly into the mind. Before Casimir's work, the vacuum of empty space could still be imagined if someone wished as something abstract, something existing mostly in equations and careful mathematics, real in theory but distant in feeling. After his prediction was confirmed by careful measurement, that distance closed a little. The vacuum had in a very real sense shown its hand. It had reached out, however faintly, and moved something. Two pieces of metal drawn together by nothing more than the quiet texture of space itself. Physicists sometimes describe this by saying that the vacuum has structure, the same way an empty room still has acoustics, still has a particular way that sound bends and settles within its walls, even with nothing else inside it. Space. It turns out behaves a little like that same kind of room, shaping what can and cannot exist within it, even when nothing else is there to notice. It may be that this idea reaches further than laboratories and metal plates. Perhaps presence does not always require something solid to be felt. Perhaps an absence shaped a certain way can still quietly press against the world around it, the way two old friends might feel closer, simply because of how the quiet in a room settles between them without either one saying anything at all. There is a quieter layer to this, still one that begins to stretch far beyond a laboratory bench, past walls and instruments altogether into the vast and largely empty spaces stretching between galaxies where something disarmingly similar to that same quiet pull may be shaping the universe on a scale almost too large to imagine. Out beyond the reach of any laboratory, far past the careful walls of any vacuum chamber, there are spaces large enough to make a galaxy look small. Astronomers call them voids, vast regions stretching across hundreds of millions of light years, where galaxies grow sparse, scattered thin, like the last few stars visible, just before a city's lights fade into true countryside dark. For a long time, these voids were simply considered empty in the most ordinary sense, places where matter had not gathered places left behind as gravity pulled everything else into clusters and filaments elsewhere. But studies indicate that even these enormous voids are not without structure. They curve ever so slightly in response to the matter surrounding them. They stretch and shift over cosmic time. In their own quiet way, they remember the shape of everything that built the universe around them. This idea of space remembering something is not simply poetic language borrowed for comfort. It points toward a real and fairly recent area of research, one that asks a delicate question. Can space itself retain a trace of events that have already passed through it? The answer gently seems to be yes. Consider gravitational waves, ripples in the fabric of space and time, first predicted by Einstein and only detected directly within the last decade. These waves are created by some of the most powerful events in the universe, such as two black holes spiraling into each other and merging into one. When such an event happens, it sends a ripple outward through space itself, stretching and compressing the fabric of space-time as it passes. The way a pebble dropped into still water sends a ripple gently outward across the surface. What scientists are still exploring and what some research has already begun to suggest is something called the memory effect. After a gravitational wave passes through a region of space, that region may not return exactly to its original shape. A faint permanent distortion can remain, a tiny but lasting shift in the distance between points in space even after the wave itself has long since passed by. It seems that space in this very particular sense does not simply let events pass through it and disappear. It holds something afterward, small, subtle, almost imperceptibly faint, but present in a way that was not there before. There is something quietly moving in that idea when it is allowed to settle. A passage stretching through space, briefly disturbing everything in its path, and leaving behind not chaos, but a soft, lasting trace. Like footprints left in sand that the tide has not yet reached. This same gentle theme echoes through other corners of physics as well. Researchers studying black holes have spent decades wrestling with what is sometimes called the information paradox, a question about what ultimately happens to everything that falls into a black hole. Does the information describing that matter simply vanish forever, or does it remain encoded somewhere, perhaps on the surface of the black hole itself, in ways not yet fully understood? What we understand so far suggests that information may not be so easily destroyed, that the universe, even in its most extreme and violent places, may resist the idea of true and total forgetting. Physicists continue to debate the details, the exact mechanism, the precise mathematics involved. But the underlying intuition shared by many working in this field leans toward preservation rather than erasure, as if the universe prefers to keep some trace of everything that has ever happened within it. There is a quieter layer to this one that most people never consider. The same fabric of space that stretches between galaxies, the same fabric disturbed gently by a passing gravitational wave, may be the very thing carrying these faint lasting impressions forward through time. Not as memory in the way the mind holds memory with images and feelings and names, but as something more elemental, a persistent shape, a subtle alteration that simply remains quietly indefinitely, unless something else comes along to smooth it away. It may be that this softens in a strange way the idea of impermanence. Events occur vast and violent, far beyond anything a person could ever witness directly. Two black holes, each heavier than millions of suns, spiraling together across unimaginable distances. And when it is finished, when the light and the energy have long since faded into the dark, something of it may still remain folded quietly into the geometry of space itself. Neuroscientists have observed something distantly similar in their own very different field when studying how the human brain stores experience. Memory is rarely a perfect unchanged copy of an event. It is closer to a subtle reshaping, a slight and lasting alteration in the structure of the brain itself, strengthened or softened over time, never identical to the original moment, but never entirely erased either. Again, these are entirely separate sciences operating at entirely different scales, governed by entirely different laws. The geometry of space-time and the architecture of human memory share no direct mechanism, but there is something tender in noticing how often nature across such different scales seems to favour lasting impressions over complete forgetting, as though leaving no trace at all may simply not be how this universe tends to work. Lying here now in the soft quiet of this hour, there is something restful in that thought, that whatever has passed through this night, through this room, through this stretch of time being spent here together in the dark, may leave behind something faint and small, even if neither memory nor instrument is ever sensitive enough to measure it directly. Not everything needs to be remembered clearly to still, in some small way, remain. And there is one place where this idea of space holding something behind it becomes especially strange, especially gentle, and especially difficult to picture. A place not made of voids between galaxies or waves rippling outward from distant collisions, but something stretching evenly across the entire universe at once, expanding everything within it slowly, quietly in every direction all the time, before reaching outward again toward that strange expanding fabric stretching across everything. It helps to come back just for a little while to something much closer, closer than stars, closer than galaxies, closer even than the walls of this room. It helps to come back to the body lying here right now. There's a fact about matter that tends to surprise people the first time they truly sit with it, even though it has been understood by physicists for over a century. Atoms, the building blocks of everything physical, including skin, bone, breath, and the soft weight of a body resting against a mattress in the dark, are almost entirely empty space. Picture, for a moment, an atom enlarged so dramatically that its nucleus, the dense cluster of protons and neutrons sitting at its centre, became the size of a marble. At that scale, researchers have found that the electrons surrounding it would not be found just beyond the marble's edge, but much farther away, circling at a distance comparable to walking several city blocks. Between the marble and that distant boundary, there would be nothing solid at all. Just space. Quiet, open, almost entirely empty space. It seems strange lying here in a body that feels so completely solid, so present, so undeniably real to consider that the actual matter making up that body, the protons and neutrons themselves, occupy only the smallest possible fraction of the space the body seems to fill. If every truly solid particle in a human body was somehow pressed together with none of that empty space remaining, the entire body would shrink down to something smaller than a single grain of sand. There is something gently disorienting about that thought, the kind of disorientation that does not frighten but softens. It does not need to be alarming. It only needs to be noticed slowly, the way moonlight is noticed only once the eyes adjust to the dark. So if atoms are mostly empty, why does the body feel so solid? Why does a hand pressed against a blanket feel like contact, like presence, like something undeniably there? The brain tends to interpret this solidity through forces, not through the simple presence of matter. The electrons surrounding every atom carry a negative charge, and these charges naturally repel one another. When one hand touches another surface, the electrons in the skin and the electrons in that surface never actually meet or merge. Instead, they push against each other through electromagnetic force, creating the unmistakable sensation of solid contact, even though on the scale of atoms, almost nothing is actually touching at all. What we understand so far suggests that nearly everything people consider physical contact in daily life, a hand resting on a chest, fingers curling gently around a blanket's edge, feet pressing softly into a mattress, is mediated not by direct contact between particles, but by an invisible negotiation of forces repelling and balancing at distances too small to ever imagine directly. There is a quiet kind of intimacy in that idea, if it is allowed to settle. The body has never actually touched anything in the way it feels like it has. Every sensation of closeness, every soft pressure felt against skin, has always been a conversation carried out by forces, never by true contact, and yet it has always felt completely real. Maybe closeness was never about things actually merging together. Maybe it was always about presence held carefully just near enough without ever needing to dissolve into something else entirely. This same emptiness extends even further into the architecture of how that mostly empty space happens to organize itself into something as specific and personal as a human body. Atoms bond together to form molecules, and molecules link together to form the proteins, fats, and structures that build cells. Every one of these connections still relies on forces acting across empty space, rarely on particles fused completely together without any gap at all. Evidence suggests that even something as familiar as the feeling of weight, the simple sense of a body pressing down into a bed, comes from this same underlying structure. Gravity pulls on mass and mass, even though if it consists mostly of empty space at the atomic level, still carries enough concentrated density in its nuclei to create a noticeable pull, gentle and constant, holding a body down against whatever surface supports it. There is something almost tender in imagining the body this way, not as something heavy or solid in the way it has always seemed, but as something built from countless small quiet distances, held together not by force in the aggressive sense, but by balance. A structure made mostly of space shaped carefully enough, held steadily enough to feel completely whole. Psychologists often note that people rarely think of their own bodies this way, rarely imagine themselves as mostly space, mostly distance, mostly quiet gaps between small points of denser matter. The mind tends to register the body as continuous, as solid, as fully present in every part all at once. But physics offers a softer, more delicate version of the same truth. A body that is in its smallest details far more open, far more spacious than it ever feels. It may be that this changes very little about how a body actually feels from the inside. The warmth still feels warm. The weight still feels heavy. The breath still rises and falls in the same slow rhythm it always has. But there is something quietly restful in knowing that underneath all of that familiar sensation there is so much room, so much open unfilled space simply waiting, simply holding everything gently in place. Lying here now, it might help to imagine that space for a moment. Not emptiness as something cold or distant, but emptiness as something close, something already present inside every part of this body right now in this exact quiet moment. And it is this same idea, the idea of vast, mostly empty structure, holding everything gently together, that begins to stretch outward again, soon this time on a scale far larger than any single body, larger even than any galaxy, into a force still only partly understood, one that seems to be quietly pulling all of empty space further apart with each passing moment. There is a kind of motion that does not feel like motion at all, one that happens so slowly, so evenly that nothing within it ever notices it is moving. To understand it, imagine a loaf of raisin bread rising slowly in a warm oven. As the dough expands, every raisin drifts gently away from every other raisin, not because the raisins are moving through the dough towards some destination, but because the dough itself, the space between them, is quietly growing larger. Astronomers have found that something remarkably similar describes the universe on its largest scales. Galaxies are not generally flying through space towards some far edge, the way an object might be thrown across a room. Instead, space itself, the very fabric stretching between them, is expanding, carrying galaxies gently apart from one another as it grows. This idea traces back to observations made in the early part of the 20th century, when an astronomer named Edwin Hubble noticed something curious while studying distant galaxies. Their light appeared shifted toward longer, redder wavelengths, a phenomenon now called redshift. And the farther away a galaxy was, the more pronounced this shift tended to be. It seemed that distant galaxies were retreating, and the most distant ones were retreating fastest of all. It is a strange, quiet image to hold in the mind. A universe where almost everything, however gently, is moving away from almost everything else, not out of any particular direction or destination, but simply because the space carrying it all is slowly, continuously growing. For decades, scientists assumed this expansion would gradually slow over time, the way a ball thrown upward eventually loses speed under the steady pull of gravity. Gravity, after all, draws matter together, and most physicists expected it would eventually draw this enormous cosmic expansion to a gentler and gentler pace. But in the late 1990s, two separate teams of astronomers studying a particular kind of exploding star called a Type 1, a supernova, found something that surprised nearly everyone working in the field. The expansion of the universe was not slowing down at all. It was speeding up. Researchers have found that this acceleration cannot be explained by gravity acting alone, since gravity should only ever pull things together, never push them apart. Something else appeared to be at work, something invisible, something acting evenly across the whole of space, gently overpowering gravity's pull at the largest scales. Scientists began calling this unknown influence dark energy, a name that admits quite honestly how little is truly understood about what it actually is. It seems that whatever dark energy turns out to be, it behaves almost like a property belonging to space itself, rather than to any object within it. The more space there is, the more of this gentle outward push there seems to be, which would help explain why this effect becomes more noticeable across enormous distances, even though it remains far too faint to detect at the smaller scale of stars, planets, or anything closer to home. There is something quietly difficult to picture in that idea, the notion that empty space, the very thing once imagined as simple absence, might carry its own subtle energy. Not energy belonging to stars or galaxies or any of the matter drifting through space, but energy belonging to space itself, present everywhere, increasing simply because there is more room for it to exist within. What we understand so far suggests that dark energy may account for a significant majority of all the energy contained in the universe, far outweighing ordinary matter, the stars, planets, and everything visible to telescopes combined. And yet, despite making up so much of everything that exists, it remains one of the least understood forces in all of physics, eluding direct detection, eluding clear explanation, eluding anything beyond careful, patient observation of its gentle effects from a great distance. There is something almost calming in that kind of mystery, when it is allowed to settle slowly rather than provoke unease. A universe willing to keep some of its deepest workings quiet even from those who study it most closely. Not withheld out of secrecy, but simply unexplained the way some feelings remain difficult to name, even when they are clearly undeniably felt. This steady expansion carries a particular kind of consequence, gentle but profound. Over enormous stretches of time, distant galaxies will continue drifting farther and farther apart, their light eventually stretching beyond what any future telescope could detect. Scientists are still exploring exactly how this story unfolds across such vast timescales, whether the expansion will continue at this same gentle pace indefinitely, or whether it might someday accelerate further still. It may be that this slow drifting apart says something quiet about distance in general, that moving apart does not always require force, urgency, or any dramatic departure. Sometimes distance simply grows on its own, gradually, gently carried along by something far larger and far slower than anything that could ever be noticed in a single moment. Lying here now in this quiet hour, it can feel almost impossible to picture this enormous expansion happening in real time all around, even within the walls of this very room. And yet the same expansion stretching between galaxies does not meaningfully reach this small familiar space, since the gravitational pull holding atoms and rooms and bodies together remains far stronger here than that faint distant push could ever overcome at such close range. So this room stays close, this blanket stays close, this breath rising and falling stays exactly where it has always been. It is only out there, far beyond anything visible, that space continues its slow, patient stretching, carrying galaxies gently apart the way silence sometimes carries two long, unhurried thoughts a little further away from each other without either one ever feeling lost. And it is in that same vast expanding stretch of space that something else has been quietly discovered. Something far older than any galaxy, a faint and steady trace left behind from the very beginning of everything, still drifting through space, still reaching even now into the quiet dark surrounding this very night. There is a kind of light that has been travelling since almost the very beginning of everything, so old, so faint that it no longer looks like light at all by the time it reaches anything capable of detecting it. In the 1960s, two researchers working with a large radio antenna in New Jersey kept noticing a soft, persistent hiss in their equipment, a faint background noise that would not go away no matter how carefully they checked their instruments. They cleaned the antenna, they checked for loose connections, they even considered whether pigeons nesting nearby might be responsible. But the faint hum remained, coming from every direction in the sky equally steadily no matter where the antenna was pointed. What they had stumbled upon almost by accident was something scientists had theorized might exist but had never actually detected. A faint, even glow of radiation filling the entire universe left over from a time soon after the universe first began to cool enough for light to travel freely. Researchers now call it the cosmic microwave background, and it is often described as the oldest light anyone can ever observe, a kind of afterglow from the early universe, stretched by billions of years of expansion, until it no longer appears as visible light at all, but as faint microwave radiation, gentle and uniform, drifting quietly through every corner of space. It seems strange to think of this radiation as light, since, By the time it reaches any antenna or telescope, it carries far too little energy to be seen by human eyes, even in the darkest room imaginable. But it is there all the same, an old and patient signal arriving from every direction at once, having travelled longer than almost anything else that has ever been measured. There is something quietly moving in that thought, the idea of something so ancient, so worn down by distance and time, still reaching this exact moment, still arriving gently into a universe that has changed almost beyond recognition since this light first began its journey. Evidence suggests that this background radiation carries within its subtle variations tiny differences in temperature from one direction to another, smaller than a fraction of a single degree. These small differences turned out to be extraordinarily important. Scientists are still exploring exactly what they reveal, but it is generally understood that these faint variations correspond to slight differences in density in the early universe, the very seeds from which galaxies, stars, and eventually planets would slowly grow. It may be that everything visible in the night sky, every star, every galaxy, every quiet point of light overhead traces its origin back to these almost imperceptibly small variations present in this same faint radiation still arriving tonight, still passing gently through this room, through this air, through this very breath being taken right now. There is something tender in imagining that. A connection so old, so faint, so easily overlooked, linking this present quiet moment all the way back to the earliest readable moments of everything that has ever existed. This same background radiation also offers a particular kind of stillness, one different from anything discussed before. Unlike stars which flicker and shift, unlike galaxies which drift slowly apart from one another, this cosmic background remains remarkably even, remarkably calm, spread almost identically across the entire visible universe. Psychologists often note that humans tend to find comfort in patterns that feel steady and unchanging, patterns that promise a kind of quiet reliability. This faint radiation offers something like that, a background hum so consistent that it has become one of the most carefully measured phenomena in all of modern science. And surrounding this ancient light is a silence unlike anything ever experienced on Earth. Out in the depths of interplanetary and interstellar space, there is no air to carry sound. No molecules close enough together to vibrate and pass a wave from one point to the next. A spacecraft drifting silently between planets exists in a stillness so complete that in the most literal sense there is no sound at all. Not faint sound, not distant sound, no sound whatsoever, regardless of how close or how dramatic the events occurring nearby might be. Neuroscientists have observed that the human brain struggles with prolonged total silence, often filling it with internal sound. Faint ringing, imagined tones or heightened awareness of even the smallest internal noise like breathing or a heartbeat. The mind, it seems, was never quite built for absolute silence. It tends to generate its own quiet sense of presence, even when the world around it offers none. There is something gentle in that tendency when it is allowed to settle. A mind that even faced with total silence reaches quietly to fill the space with something. A faint hum of its own, not unlike the universe's own faint hum, drifting steadily through every corner of empty space. Maybe this is one of the softest truths of this entire story so far, that neither space nor mind seems entirely comfortable with absolute nothingness. Both in their own separate and very different ways seem to quietly resist it. Space fills itself with faint radiation fluctuation structure. The mind fills itself with thought sensation, a steady internal hum that rarely if ever falls completely silent, even in the deepest hours of night. The mind, it seems, has been keeping something still and patient all along, something that does not need loud silence or dramatic stillness to feel restful, only a soft, steady hum quiet enough to drift beside the same way this ancient light has been drifting patiently gently for longer than almost anything else that has ever existed. That quiet hum the mind keeps even in deep silence turns out to have a great deal to do with how it perceives space itself. Not just the vast empty space stretching between galaxies, but the much smaller, much closer space surrounding a body lying still in a dark room. The brain tends to construct a sense of surrounding space using information far more limited than it might seem. In a fully dark room, the eyes provide almost nothing useful. There are no edges to trace, no shapes to anchor against, no clear sense of how far the ceiling sits above or how close the nearest wall might be. And yet the mind rarely feels lost in that darkness. It tends to fill the space anyway, constructing a rough, comfortable sense of size and distance based on memory, on familiarity, on the soft architecture of a room learned long before the lights were ever turned off. Neuroscientists have observed that this kind of spatial construction relies heavily on a small structure deep within the brain called the hippocampus, along with nearby regions that work together to map and remember physical space. Certain cells within this network, sometimes called place cells, become active depending on specific locations a person has occupied before effectively building an internal map that persists even when the eyes can offer no direct information at all. It seems that the darkness in a familiar room rarely feels like true emptiness because the mind is not actually relying on what the eyes can see in that moment. It is relying on a quiet internal map, built slowly over time, drawn from countless previous moments spent in that exact space, now activated softly in the absence of any other information. There is something comforting folded into that deer when it settles slowly. The darkness around a sleeping body is rarely as unfamiliar as it might first appear. The mind has already mapped. It already walked through it, already learned its quiet edges long before tonight. This sense of spatial awareness becomes especially interesting when there is genuinely no information at all to draw from, such as in completely unfamiliar surroundings or in carefully designed sensory deprivation environments used in certain areas of psychological research. Studies indicate that when sensory input is reduced significantly, whether through extended darkness, silence, or controlled isolation, the brain does not simply remain blank or empty in response. Instead, it tends to generate its own internal experience, sometimes filling the void with faint imagined light sound or even a subtle sense of motion that has no external cause whatsoever. This single idea echoes something already touched on earlier. In this story, the apparent reluctance of both space and mind to remain in true total absence. Just as a vacuum chamber resists being entirely free of particles, just as zero-point energy resists complete stillness, the human mind faced with extended emptiness seems to resist remaining truly blank as well. It reaches quietly to fill whatever space has been left open. The brain tends to interpret this reaching not as something alarming, but often as something gentle, sometimes even pleasant, particularly in the relaxed, drifting moments just before sleep. This is the same window of time when people commonly experience hypnagogic imagery, faint dreamlike fragments of light, shape, or sound that arise spontaneously as the mind eases out of full wakefulness without yet entering deep sleep. It may be that this gentle, spontaneous activity is simply what a quieting mind naturally does when external input fades low enough to allow it. Not manufacturing anything urgent or meaningful, but simply continuing its quiet hum, the same way distant stars continue to emit faint light long after the events that created them have already passed. There is a particular kind of trust folded into that process, even if it rarely feels like trust in the moment. A willingness to let the mind drift without needing every sensation to be explained, without needing every faint shape or sound to mean something specific. Just allowing it to happen softly, the way clouds are allowed to form whatever loose shapes they happen to form without anyone needing to ask why. This same quiet construction of inner experience extends into how the body senses its own position in space even with eyes fully closed. There is a sense often overlooked entirely called proprioception, the body's ongoing awareness of where its own limbs are positioned even without looking at them directly. Lying in the dark right now, it is entirely possible to know without any visual confirmation at all exactly where an arm rests against the mattress, exactly how a leg has settled beneath a blanket, exactly how the head tilts gently against a pillow. Researchers have found that this sense relies on countless small receptors throughout muscles and joints constantly relaying quiet, continuous information to the brain, an entire silent conversation happening throughout the body at every single moment, one that almost never reaches conscious attention unless something draws focus toward it directly. It seems that the body, much like the space it moves through, is never truly without information, never truly without some quiet form of awareness, humming gently beneath the surface, even in complete stillness, even in complete darkness, even in the deepest, most restful hours of night. There is something quietly reassuring in realizing that this entire body resting here right now is held not just by a mattress, not just by gravity, but by an entire unseen network of awareness, signals, and gentle internal mapping that has been working quietly in the background the entire time without ever needing to be noticed directly in order to keep doing its slow, patient work. And as the mind continues its own, drifting deeper now than it was even a few minutes ago, there is one final gentle thread still waiting. One that brings this entire story back toward where it first began, back toward that very first quiet question about whether anything in this universe was ever truly completely empty at all. Back where this all began, there was a small glass tube, a thread of mercury and a tiny gap of nothing sitting quietly above it. That gap seemed at the time like the closest thing to true emptiness a person could ever capture. But everything explored since then has gently suggested otherwise. Empty space, it turns out, may be one of the least empty things in the entire universe. There is a way of gathering all of this together now, not as a list of facts to remember, but as a single soft impression, the kind that settles slowly into the body rather than the mind. Every vacuum ever created on Earth, no matter how carefully engineered, still carries faint traces of matter, stray atoms, refusing to fully leave. Beneath even that at a scale far too small to ever see directly, energy itself never quite reaches zero flickering, instead in brief borrowed moments that appear and vanish almost faster than thought. Two metal plates placed close enough together can feel this flickering directly drawn quietly toward each other by nothing more than a subtle imbalance in the texture of empty space. Out beyond any laboratory, this same fabric stretches across vast cosmic voids, curving gently in response to everything that has ever moved through it, perhaps even retaining a faint lasting impression of events too violent and too distant to ever witness directly. And further still, this fabric expands slowly and evenly in every direction at once, carrying galaxies apart from one another, driven by something scientists have not yet fully named. Simply calling it dark energy, an honest admission of how much remains unknown. Threaded quietly through every part of this story is a single recurring pattern, something easy to miss the first time through, but unmistakable once it has been noticed. At every scale explored so far, from the smallest quantum fluctuation to the largest stretch of intergalactic void, the universe seems reluctant to remain in true, complete absence. It seems that wherever something might be expected to be perfectly empty, perfectly silent, perfectly still, something small and quiet tends to remain instead. This is not a dramatic discovery, the kind that rewrites everything at once. It is a slow accumulating impression gathered patiently across centuries of careful observation, from a mayor's curious hemispheres to a physicist's mathematics about energy borrowed, and returned to two researchers in New Jersey puzzling over a persistent, unexplainable hiss in their equipment, each piece on its own modest. Together something larger, a universe that seems in its own quiet way to prefer presence over absence, even when that presence is too faint to ever be directly felt. It may be that the human body lying here now in this soft, settled dark reflects something of that same pattern. A body made almost entirely of empty space at the atomic level, and yet never once feeling empty. A mind capable of sitting in complete silence and yet rarely staying silent for long, quietly generating its own faint hum, its own soft internal motion, simply because true stillness, true emptiness, may not be something either space or mind was ever truly built to hold. There is something gently reassuring in that thought if it is allowed to rest here a while longer. The quiet of this room tonight, however still it feels, however empty the dark space surrounding this body may seem, is likely not empty at all. It is in its own way behaving exactly like the rest of the universe always seems to behave. Holding something faint, holding something small, holding something present even where presence is hardest to notice. Psychologists often note that feelings of solitude, particularly late at night, can sometimes carry an edge of unease, a sense of being entirely alone in a vast, indifferent space. But everything gathered here tonight gently suggests something softer than that. Even the most distant, most isolated stretches of the universe carry faint traces of something. A few wandering atoms, a flicker of borrowed energy, an old patient light still arriving from the very beginning of everything. Aloneness in the way the universe seems to understand it may never be entirely complete. What we understand so far suggests that this same gentle principle extends quietly into far smaller and more familiar moments as well. A quiet room is rarely as empty as it feels. A still body is rarely as motionless as it feels. A silent mind is rarely as blank as it feels. There is almost always something faint continuing underneath, some small persistent hum, holding everything gently in place. Whether or not it is ever consciously noticed, it seems fitting somehow that a story which began with a question about empty space would slowly arrive here at this very ordinary, very human moment. Lying still, breathing slowly, surrounded by darkness that only seems complete. The same darkness that at every scale studied so far from atoms to galaxies has never once revealed itself to be truly fully empty. Maybe that is enough to carry into sleep tonight. Not a fact to remember, not a conclusion to hold on to, just a soft, settled feeling. That stillness was never the same as absence. That quiet was never the same as nothing. That even here in this dark, ordinary room, surrounded by a kind of silence that feels complete, something faint and steady, continues quietly underneath, the same way it always has everywhere for longer than anything else that has ever existed. And it is in this same quiet place, this same soft settled stillness, that the night now begins its final gentle turn, easing further down, letting go of everything except the slow, unhurried rhythm of rest itself. There is one more quiet place worth visiting tonight, smaller than any galaxy, gentler than any equation, closer than anything discussed so far. It is simply the space inside this very room right now, in this exact settled moment. Researchers studying sleep have found that the body as it eases toward rest undergoes its own quiet kind of stillness, one that, much like everything explored tonight, is never truly complete. Breathing slows but never stops. Heart rate eases but never fully quiets. Brain activity shifts into slower, gentler waves. but never falls into true silence. Even in the deepest hours of sleep, something continues. Some faint hum, some quiet motion, something present the way it always seems to be, everywhere this story has travelled tonight. It seems fitting that a story about empty space would end here in a body that is never empty either. A body resting quietly surrounded by darkness that only seems complete. Atoms, mostly space, holding their shape softly together. A mind mostly quiet, still carrying its own faint, steady hum beneath the surface. There is nothing left to explain right now. No new fact waiting to be uncovered tonight. Only this, the dark, the breath, the quiet, ongoing hum of a body and a universe that have never once required true emptiness in order to feel like rest. The room grows softer now, the thoughts grow shorter. Somewhere far above this room in the unseen dark old light is still arriving faint and patient the way it always has. Somewhere far below thought the breath continues slow and even, asking for nothing. The blanket settles, the body settles, the mind gently lets go of the need to follow anything further. Just this, a quiet room, a soft dark. A faint, steady hum continuing on somewhere underneath everything. Drifting now. Further, still here, still soft, still warm, just resting, just this.